Hello there and welcome to Ancient Theories channel. Lately there was a lot of videos going on in the internet about those ancient Etruscan vases, and to be sure, I am one of those YouTubers who did made a video about those. And in those videos, a lot of people talks about the precision of those vases and precision of any ancient artifacts. So, you see, to deliver a high precision on artifact, you need to design it with math. And to design anything, you need to use geometry. And how good geometry can you create without modern tools? That's the right question, and I will try to answer it today. And what is geometry? So geometry is the kind of math you are learning in your middle school, and you are drawing a lot of circles and triangles and maybe some squares. But to be honest, geometry is all about circles. How precise can you draw a circle? How precise can you draw a square in a circle? How is related circle to the triangle, and so on and so on. So let's try to create a perfect circle, okay? It's common belief that ancient people used some rope and sticks to draw a circle. We do this today on our middle school classes with simple tools, but they use string and some sticks. And I'm using beeswax because they used beeswax or clay, later on papyri, and so on. And I'm doing the same thing as they did. Let's try this, okay? Let's look how precise this method is. Because it's all about the measurement. How precise can you make a vase? Well, a vase is basically a lot of circles, but in 3D. And those circles have to be perfect, right? To get a perfect vase. So let's measure every single one circle, okay? And we will have perfect vase. But to get the perfect vase, we need perfect circle. So let's try to make a perfect circle with simple tools. And let's go. And you may also call me wrong on this, because I'm telling you that somebody 5,000 years ago used math to design a vase or anything. But hey, there is another example of that, and it's the ankh symbol. So you see, the ankh symbol is actually made with circles. It's made with math. And you can get this guy on YouTube who is showing you this. And I don't know how to pronounce his name, so I will just show him here, and that's it. You can go there and watch him create an perfect ankh with basic tools. And I am going to make a pretty good circle here, but it will not be perfect for now. I am using my caliper to take some measurements, and I am using this string to get these straight lines. And as you may see, those measurements are not the same. There is deviation of some sort here, and it's not the best circle. It will be okay for any middle school classes, but it's not any goods for any construction work or so on. But to be honest, it doesn't need to be perfect. It only needs to be close to perfect for most of the activities. But let's be crazy for a moment. Let's try again. I will scrub these beeswax and cleave it, and made another one, but this time I will use this metal piece It's my drill, but it can be bronze drill, anything. It's not like only a metal piece in D-wax. I am using this because I think it will be a better circle now with something less elastic than wood, and I will just use this wooden piece to carve the next circle. But as you have seen, I made some grooves on my stick to get better grip on the rope. And I'm feeling that this circle way of measurement was a real thing in most of this region in ancient times. I'm talking about Mesopotamia, ancient Babylon, and Egypt, and I think even in Crete, the island of Crete, I think all of those people used this method of measurement by using circles, perfect circles. And those maybe meant, I don't think it's the best circles, but I think they used this because it was the closest fit to perfect the geometry shape. And after that, if you have a circle, you can define any other rectangular or triangular or any other 2D shape. And with those, you can make a really good a plan for a building. You can create some blueprint for your tools and so on. And your tools and your blueprints and so on will be only as good as your circles, only as good as your triangles. And so they used some good technique to draw circles. And you can see those circles, those measurement way of thinking in their art on many other occasions. Okay, and this circle is pretty good, better than the first one, still not perfect, but I will go one step further. Because you see, if I would like to inscribe any triangle in this circle, and if this triangle I am inscribing is the right angle triangle, then its hypotenuse of this triangle inscribed in a circle must be its diameter, the circle diameter. And if it's placed in this way, I can measure its length, and I can calculate the cosinus function of this angle and try to establish if this angle truly is right. And this way, you'll know for sure if my circle is close to perfection. And if it's close to perfection, then my triangle is truly the right angle triangle. And that's how I'm going to prove my point here. And this triangle won't be perfect, but it will be close. Okay? Still not 4 microns to perfection, but pretty close. And you should also know that I am doing this with this piece of wood, one piece of metal, and elastic rope. And it's yarn, actually. It's grape yarn. And my color tools are not necessary here. I am just diving my hole in this beeswax because Reaxi is pretty sturdy for any other drill hole, because this I am losing my punning here. You can easily use hot water to dissolve beeswax, okay? But if the beeswax is cold, it's pretty sturdy, okay? And I am not going to destroy my beeswax. I am just trying to scribe in the beeswax. And you can also know that we are still today using beeswax to scribe in it for any homemade jewelry in silver, in gold. We use also beeswax to create some pretty awesome blueprints for manufacturers, and the beeswax is actually also used for artists to create some prototypes of sculpture. Those are the measurements, and as you can see, those are my calculations. We have here a pretty close angle, but the error is still about 2.5 degrees. It's about 8% of error. It's still not perfect, but you will see I will get a really, really good circle in a while. I will just change my elastic yarn to a simple wire, and I am using aluminum wire, and you may also know it's just office clip. And I am also using a second drill to scribe, because to be honest, using wood to scribe perfect circle isn't the best choice. Okay, so you can tell me, hey, but they didn't have those steel or tungsten or any other drills then, but they had some really sharp bronze sticks, okay? And we know they have, and I'm just using this to scribe in a freaking beeswax. It's okay, because it doesn't matter if it's steel or bronze or even, I don't know, pretty any metal like aluminum, to scribe a circle in a freaking beeswax, okay? And as you can see, I'm also using this clip made of aluminum, which would be better if it would be, okay, the bronze clip would be better than aluminum one, okay? And it doesn't need to be a clip. It could be any sort of wire or, wait for it, any circle made of wire. And then depending on this diameter of this wire circle, I will get bigger or smaller circle of my own. And as you may remember, those tools, so wire circle and a carving tool, were presented in any ancient times in their art, because you can see this in ancient Mesopotamia and ancient Egypt. Before the Ankh symbol, we have a Shen ring, which is actually a circle and a stick, and somebody speculates that this is made of yarn, or it's made of any other rope, but maybe it's made of bronze wire. Keep in mind that those measurements of the diameter of this circle is perfect for my caliper. But keep in mind that these digital calipers have an error range of 10 to 20 microns, okay? And what's even more interesting is that photogrammetry, which was used to scan those vases, also have about 10 microns of error here and there. And I know there are also measurements in the lab, okay? I'm just telling that's the error I am dealing with. It's 10 to 20 microns. And still, we are still under the 25 of microns of error. So we are dealing with the high precision class of objects, okay? And my holes in this beeswax for this triangle are also messing up with my measurements, okay? It's not much, but it's like 2, 3, 5, 8 microns of error because of those holes. And my caliper measures those holes also. So maybe my circle is better than my triangle because of those micro literally microns of errors due to those points made by my drilling hole when I'm trying to mark those triangle. Okay? And here is the math. Okay? This triangle is very close to perfection. It's only 0.17855 of a degree from actual right angle. It's pretty awesome, right? And in percent, it's only 0.198% of error. It's quite good, okay? And if I am lucky enough, then probably my circle is even better due to those marks made by my drill, which are not perfectly aligned with the circle, and my collider took those holes, and these measurements made by me are a little bit off because of those. And if so, then my circle is even better. So that's how precise I can get with a pretty simple wire and two the drills, okay? It then also it was bronze wire, it could be bronze drills, bronze sticks, sharp sticks made of bronze. It's okay. It doesn't need to be anything else. It doesn't need to be perfectly aligned or anything like that. It's just carving circle in uneven surface of wax. You may also see this in this video. It wasn't even surface. It was just a beeswax, okay? I didn't use those surfaces from the modern wooden planks. I used this surface, of rough surface, to carve this on, okay? It just doesn't matter. The circle is still pretty good. Look at those cosinus function. It's really close to zero. And in modern classic physics, we are dealing with this assumption that lesser angles can be just zero, and it's less than 3 degrees can be seen in any harmonic motion. In classical physics, not relative physics, not quantum physics, I'm talking about classical physics, okay? 3 degrees, cosinus of 3 degrees can be seen as 0.00000. And as you may see, my right angle is pretty close to that. So can I just say I could create some bronze circles with this method of thinking and measure my vase with those rings to make sure they are perfect? I could also use some light source in a dark room to see if a light can go through these little holes between my rings of bronze made by this method and those granite or dolerite vases. I can measure it that way. I'm not saying it was measured by ancient people this way, and telling it could be made by them, because there is no advanced technology required to do so. Only right attribute. Till we meet again.